All right, so for the concept today, our objective is to find the sine, cosine, and tangent ratios of an acute angle and a right triangle. So we're still going to be looking at right triangles. But now we're adding sine, cosine, and tangent ratios. So we need to figure out how to label the sides of a right triangle. We briefly talked about this yesterday when we talked about the hypotenuse. The other two sides, I just call them A and B for the legs. But for today, for sine, cosine, and tangent, we need to label them as like the opposite side and the adjacent side. So if we look at the first one, it says is the hypotenuse. So that's always going to be the side across from the right angle. So just like we saw yesterday, from the right angle, the side opposite is going to be the hypotenuse. Likewise here, again, from my right angle, the side across from the right angle is going to be the hypotenuse. And then we have the side opposite. So the side opposite a given angle is the side across the triangle from the angle. So if we look at the first example here, it's talking about angle A. So my angle A is right here. Angle A is right here. So the side opposite angle A is across from the angle. Okay? So across from angle A is the side opposite. In this case, it's talking about angle B. So now I'm looking at angle B for the second example, or the second triangle. So now my angle of reference changes to the top. So then across from the angle, this is now the opposite side at the bottom. Okay. And then we also have the adjacent side. The side adjacent to a given angle is the side next to the angle that is not the hypotenuse. So for this case here, for angle A, the one that's next to angle A would be this one, because this is the hypotenuse. So the one that's not the hypotenuse is the adjacent side. And then likewise with angle B on the other triangle, the one next to the angle is the vertical side that's not the hypotenuse. Okay, so we're going to practice labeling the triangles. Let's go ahead and look at our first example here. The directions say to use angle D. Using angle D, label the sides of the right triangle as the hypotenuse, the opposite, and the adjacent side. So again, you always want to look for the angle, the right angle is right here. So yesterday we saw that the side across from the right angle, we always call that what? The hypotenuse. Okay? And then the directions again say using angle D. I'm looking at angle D, which is right here, angle D. I'm going to put an arc for the angle so that I know this is the angle that I'm looking at. And then directly across from the angle is the side opposite angle D. Which then leaves us with the other side, the side DF. Side DF would be the adjacent side because it's next to the angle D and it's the side that's not the hypotenuse. Okay, so let's do it again with the next example. Again, I like to start with the right angles. I'm going to put a star in my right angle. So we'll cross the right angle. We call that what? Hypotenuse. Good. And then looking at the angle, I'm looking still at angle D. So angle D is right here. So across from the angle is which side? Opposite. Good. Which then leaves you with the other side would be the adjacent side because it's next to angle D. And it's the side that's not the hypotenuse. Okay. All right, so I'm going to have you guys practice labeling the sides as opposite, hypotenuse, or adjacent. All right, so again, now that we have practiced labeling the sides, now we're going to learn about the trig ratios. So a trigonometric ratio is a ratio of two sides of a right triangle. And the three primary trigonometric ratios are sine, cosine, and tangent. Sine, cosine, and tangent. There are more, but when you get to like pre-calculus or calculus, if you get to those classes, you'll learn about like secant, cosecant, and cotangent. But for now, for math 3, we're only looking at sine, cosine, and tangent. Okay. So we see the sine of A is going to be the length of the side opposite angle A over the length of the hypotenuse. Okay. This is at the bottom of your notes. Then we have our cosine of A is the length of the adjacent side divided by the length of the hypotenuse side. And then we have our tangent is the length of the opposite angle over the adjacent. Okay. And so somebody came up with this mnemonic right here at the bottom. We have SOHCAHTOA. A lot of people say SOHCAHTOA to remember. So it's a mnemonic that can help you remember the definitions. So is going to be sine over adjacent. Sorry, sine is so opposite over hypotenuse. And I like to write them as fractions. So is opposite over hypotenuse. Cosine we have is ca, so adjacent over hypotenuse. And then our tangent is toa, is opposite over the adjacent side. SOHCAHTOA. All right, so let's look at an example. Our first example, this is now on the back of your notes. On the next page, we have the directions say to find the following and simplify if possible. Okay, so the very first thing you want to do is label your sides just like we practiced. So find your right angle. The side across from the right angle is what? What did we label across the right angle was hypotenuse. Good. And then I need to identify what angle I'm looking at. In this case, it says angle A for all three of those. So my angle A is this bottom one. So I'm going to put an arc at the angle so I know that's the angle I'm looking for. And then the side across the angle, we labeled that as what? Opposite or adjacent? Opposite, thank you. Which leaves you then with 8 being the adjacent side. All right, then I have sine, cosine, and tangent. So I like to write them. A lot of people just write SOHCAH. Oops, that's supposed to be an H. SOHCAH, and then tangent is TOA. But I like to write them as fractions. So my sine is so opposite over hypotenuse. So my opposite side, I see up here, my opposite side is 6. So I'm going to put a 6 over the hypotenuse side, and my hypotenuse side is 10. So 6 over 10. But the directions say to simplify if possible. So 6 and 10 are both even, so I can actually reduce by 2 for both of them. So 6 divided by 2 is 3. And 10 divided by 2 is 5. All right, then for cosine is cos. So cos is adjacent over hypotenuse. So my adjacent side is what? Adjacent side is 8. So I have an 8 over the hypotenuse side. My hypotenuse is 10. And again, those are both even, so I can reduce by 2 again. What's 8 divided by 2? 4. And 10 divided by 2 is 5. All right, then for my last one is tangent. So I have TOA is the opposite over the adjacent. So my opposite side is 6. And the adjacent side is 8. And again, I can reduce by 2. So 6 divided by 2 is 3. And 8 divided by 2 is 4. So sine, cosine, and tangent. My simplified fractions are 3/5, 4/5, and 3/4. All right, let's look at another example with a radical this time. So let's look now at the next example. We have a square root of 33, a 7, and a 4. So one more time, we need to practice labeling the sides. So my sides, I want to look at the right angle first. Across the right angle is which side? Hypotenuse, because it's across the right angle is the hypotenuse. And then I need to figure out the angle. What angle are we looking for? D. Right here it says angle D, right? So my angle D is the angle of reference. So then across the angle, is that the opposite or adjacent? Opposite. Which then leaves you with root 33 is the adjacent side. Again, sine is so, cosine is ca, and then tangent is toa. So I'm looking for the opposite side. What's my opposite side? The value of the opposite side is 4. Good. Over hypotenuse is 7. I don't have to simplify it because 7 is prime, so I leave it as 4 over 7. Cosine is ca. That's the adjacent side is what? Square root of 33 over hypotenuse is 7. That's okay because I don't have the square root in the denominator. If it's in the numerator, then that's fine. And 7 is prime, so I can't really simplify that any further. Tangent is TOA, so my opposite side is 4. Over the adjacent side is the square root of 33. But again, we saw in the prior knowledge, this we cannot have a square root in the denominator. So what did we learn? How do we get rid of the square root in the denominator? Multiply both top and bottom by root 33. That's my ratio of 1. So then this becomes 4 times the square root of 33 over the square root of 33 squared. And again, the square root cancels out the squared. So my final answer is going to be 4 times root 33 over 33. And you guys can skip this step. I just wanted to kind of review in case if you forgot. y, the square root cancels. Okay, this is my final answer. 4 times root 33 divided by 33. All right, so looking at this example now, we have, notice I have a 2, a 6, but this time I have a 2 root 10, a 2 root 10. So let's see what happens here. So again, first let's label the sides. I have my right angle. Across the right angle is which side? Opposite, adjacent, or hypotenuse? Hypotenuse. So I'm going to put H for hypotenuse. And then what angle is my reference angle? F. It's asking for angle F, which is right here. So I'm going to put my arc for angle F. That means 6 is which side? Opposite, good. And then the 2 is the adjacent. And then I'm going to do SOHCAHTOA. Sine is so. That's going to be what over what? 6 over 2 root 10. Notice I can't have a square root in the denominator, but I also have a fraction. I have the 6 over 2. So here I want to reduce by 2. Reduce the 6 and the 2 by 2. So if I 6 divided by 2, that's going to be what? 6 divided by 2 is 3. And 2 divided by 2 is just 1. So that's just going to go away. And it's going to be root 10 and then denominator. Okay? But I cannot have the root in the denominator. So times root 10 over root 10. My final answer is going to be 3 root 10 over 10. All right, so now let's look at cosine. That's ca. Cosine is ca. So my adjacent side is what? 2 over hypotenuse is 2 root 10. And again, I can reduce by 2. I can't spell today. Reduce by 2. So 2 divided by 2 is what? 1. And 2 divided by 2 again is 1. So it's just 1 over root 10. But then we rationalize root 10 over root 10. So 1 times root 10 is just the root 10. And the root 10 times root 10 is going to be root 10 squared, which is just going to end up being 10. The square root goes away. All right, then tangent is TOA. What's my opposite side? 6, and the adjacent side is 2. And then I can again reduce by 2. What's 6 divided by 2? 3. And 2 divided by 2 is just 1. So 3 over 1 or just 3? Okay. All right. All right, I'm going to go ahead and stop the lesson here until you have like about 9-ish minutes to work on the assignment.